So a lot of our customers are running Windows Server on-prem, and they're looking at different ways they can leverage the cloud, how they can migrate their workloads to the cloud, but there's still reasons why they keep their workloads running on-prem, and these are absolutely valid reasons. Now, however, they're looking into options, how they can take advantage of the cloud and use Azure hybrid services to make their on-prem environment even better. Now, to connect these services, you can go out today to the Azure portal and you can log in and basically choose the service you want to use, like Azure Site Recovery or Azure Update Management, and then basically install the necessary agents and set up the environment. However, with Windows Admin Center, which is a free download for Windows Server, you can basically go out and simply and very easily connect Azure hybrid services by logging in with your Azure account and then setting up the right subscriptions for the right service. And so you can easily connect different services like Azure Backup, Site Recovery, Update Management, and even Azure Monitoring if you want to.
Hey, thank you so much, Thomas. It's always good to see him. And we're going to go ahead and start talking about this today. We got some great stuff as far as hybrid cloud is concerned. So my name is Jay Gordon, and welcome back to Azure FunBytes. And what do we do every week? Well, we get together, we talk about products, services, and the other complementary things that you can use to have a great Azure experience. So let's get started by one. Today we're going to be talking about OpenShift, which is a open source platform that can help you work with a number of different types of clouds, your on-prem environment, all these different things to help make your Kubernetes implementation a little bit simpler. So if you have multiple providers that you're going to be using, like I said, your data center, your cloud, you can kind of bring these all together and manage all these different clusters. So to help me understand a little bit more, because I'm a little green on OpenShift, I'm not going to lie to you, I am going to welcome JJ Asghar. Hey, JJ, how are you today?
I'm great, Jay. How you doing, buddy?
I'm doing really well. I'm really thankful for you to be here. It's always fun to kind of have conversations about different types of software, how we can utilize it in our cloud environments, and how we can actually bring together these hybrid experiences that we expect to just work sometimes.
Absolutely. By the way, is this the Triple J show?
Yeah, I
J.
think
Yeah.
we're JJ and J. Yeah,
Yeah, there you
we
go.
we've definitely tripled down on J's. And
There you go.
so one of the things I wanted to try to give everybody before we kind of get started, JJ, is we've got some stuff to roll through. I'm going to go through it really quick. One, we've got our poll. So every week we have a poll. We ask some questions and see how you are utilizing the different services that we talk about. And so today, I'd love you to go to Microsoft Learn TV. You can go ahead and vote on it right now. So the poll is, are you implementing OpenShift for your Kubernetes deployments? If you are, let us know. We'd love to hear about it. And then I also want to remind you that while you're at it, there is Microsoft Learn. And Microsoft Learn is a free platform that you can use. It helps you gamify the process of working and understanding a lot of these concepts. You'll be able to gain experience points. You'll be able to get up to speed on a lot of the different things that are part of Azure. And if you take a look at it really quick, hello, where are you? There you are. You'll see we've got these learning paths so that whatever it is you'd like to learn underneath the Azure or DevOps or cloud world, we've got something for you. And so, we've got through the opening portion of our show, JJ. But now, before we kind of get into the meat and potatoes of this episode and talking about OpenShift, I'd love to first ask you a little bit about you.
Mm-hmm.
So, JJ, you've been in the industry, what, a good almost 20 years now, something like that?
About right. Yeah. Right.
Going from everything from working at Dell, HP. You worked as an engineer for the University of Texas. But I want to hear it in your own words. How'd you get here?
Yeah. The short of it is I fell backwards. I've always been the type of engineer that kind of goes for the things that no one else wants to do. So I've just taken responsibilities over throughout my career. I'm an old sysadmin, right? I mean, graybeard joke aside, give me bash and give me curl, and I can rule the world, kind of thing.
Yeah,
And
I completely can relate to that. I absolutely can relate to that. Still a Bash fan. Will never give up on my love for Bash.
There you go. But by the way, I do want to throw out, I've actually gone through the Python and Go course on Azure Learn, and they are solid. I am very, very, very impressed with what y'all did there.
Yeah, there's so many great different subjects that people can leverage that help them, learn about what it is that they want to learn in these different learning paths. So if you want to take some time around Go, if you want to take some time around Python, you want to take some time around Kubernetes, and even one of the latest things, just talking about, say, DevOps implementation and pipelines, and there's a whole portion on GitHub Actions. So I love all these things. I love how it all comes together. And hey, let's say hi to our old friend Andrew Clay Schaefer, who is right now saying that there's a JJ Stan account, and it's hard not to be a Stan. So tell me a little bit more about what you're doing at IBM now.
Yeah, thanks. I'm a developer advocate for the IBM Cloud. I'm just kind of here to talk about IBM Cloud and the hybrid cloud story, where the world is no longer just one cloud. There are multiple clouds out there, and there needs to be a platform that allows developers, who I am advocating for, hence the term developer advocate, to give velocity to, right? Like, as a developer, you want to get your code out as quickly as possible. And we think we have a really awesome story here that, as we walk through this, I believe the developers on watching this will be pretty impressed.
Very cool. Very cool. So I know you put together a little bit of an explanation of everything, but I want to give you a chance if there's anything that you think that people should know about hybrid cloud before we kind of dive deep in, because I think that hybrid cloud is a really great conversation. I had one with Thomas Maurer, who was on the top of the show with that little pre-recorded video. And we talked a lot about hybrid cloud, but I'd like to get your perspective. What do you believe is the ideal hybrid cloud implementation?
Whoa, how much time do we have? No, I kid. In all seriousness, being that the vendor lock-in that happens with a lot of clouds now, the idea that we need to be successful as engineers and as developers, you need to look at multiple clouds to be successful. You can't just have everything. You can't have all your eggs in one basket. I mean, yes, the joke of, all the meme stocks and all, and people putting all their money in those things, but a real investor diversifies, puts things in multiple different places to make sure they first either have redundancy or they have, safety, because it's your business, right? It's your business.
Absolutely.
But you also need some level of standardization, because there's so many different ways of the clouds implement different tooling, different things. Like something like Kubernetes and OpenShift come along and give the developer the standardization communication, so you can worry about your infrastructure and operations engineers worrying about the nuances of all the different clouds, where a developer, especially in the enterprise space, can focus on getting the business value out as quickly as possible, instead of worrying about all the different portions that is required to know how to run on the different clouds. Does that make sense?
Yeah, I think it does. And so can you tell me how you feel OpenShift kind of, like, we can talk exactly about what OpenShift is in just a moment. How does OpenShift kind of, I don't know, let's actually start there. So let's start with, like, what exactly OpenShift is, and then we can talk a little bit how it fits into this hybrid cloud story.
Sure. So the short of it is OpenShift is like, if you want to TLDR this whole thing, or I guess TLDW, because you didn't read, you watched it. Yeah, no. The short of it is OpenShift is just Kubernetes with an opinionated level on top of it to give velocity to developers. That's all it truly is. It's Kubernetes underneath the hood with some things that developers, like, choices already made for you. Actually, we should have brought up landscape.cncf.io if you don't mind, real quick.
Sure.
So the joke is, and not really a joke, but it's actually serious in a lot of ways. If you go to landscape.cncf.io, which Jay will bring up here in a second, and you look at it, it is overwhelming. Like, I'm not going to lie, right? Like, just scroll through this thing. There's so much going on here. And there's so many different offerings, so many different products, so many different services, that this is all part of the cloud native ecosystem. Now, if you have the
Go ahead.
Oh, if you have the experience and the knowledge, by God, God bless and keep going. Like, absolutely. But that requires a lot of effort and time. And if you're a business and you want to move to the cloud native ecosystem, this is overwhelming. OpenShift comes along and gives you an opinionated choice of all those different products or projects or whatever you want to call them in the landscape, and give you a path to success to be able to get your business out there as quickly as possible. Because what are we doing as professionals? We're trying to make money, right? What is the goal? To make money, right? Like, that's why we're doing this as engineers and as professionals. And OpenShift gives you that path without having to be overwhelmed by something that is the landscape.cncf.io.
That's gives me a lot of information. And so how does this all fit into your hybrid cloud solution? Is it just the fact that it's opinionated?
Yeah, it's a nuanced question. But the short of it is because it's a unified platform across all the different major clouds and also on-prem, it allows the engineer and the development teams to be able to run the exact same way on every single cloud, which eventually, with the demo that I'll show in a little while, like, even though we're doing this on Azure, we're talking about the Azure cloud here, I'll be doing this on a different cloud, and we use the exact same commands, the exact same process, and we get the exact same output at the very end, which is, when a developer sees that, that's catnip, man. That's
Absolutely
straight up catnip.
And so I want everyone to know that if you've got questions about OpenShift or Kubernetes, we're here for you today. The chat is either in your native platform, so if you're using LinkedIn, Twitch, YouTube, or you can head over to Learn TV, where we're asking the poll: are you currently implementing OpenShift for your Kubernetes deployments? Love for you to share that with us. I know, JJ, we've got about 45 minutes to kind of have this conversation, and I'd love if I could bring up your screen and maybe give you a chance to talk a little bit about Kubernetes and OpenShift in way too short a time.
Absolutely, I'd love to. Thank you.
Great.
So, this is my typical kind of, like, I got 15, 20 minutes to talk about OpenShift and Kubernetes. And the reason why I say, again, and to reiterate this again, the reason why I say Kubernetes/OpenShift is because OpenShift is just Kubernetes. And you'll actually hear me, not accidentally, almost sometimes purposely, flip them back and forth, because they really are just the same thing.
Gotcha.
So I like to build off of some building blocks to make sure that we all have, like a common vernacular. And if you know nothing about this ecosystem, the beauty of this talk, or the beauty of these slides, is it gives you the foundation, so you'll be dangerous enough to be able to delve a little bit deeper into this space. So everything's built off of something called a container, right? And I was told by my marketing team that I'm not allowed to use the Docker image, so of course I'm yelling at the cloud. I gotta love that. But in all seriousness,
I like it.
Thank you. In all seriousness, everything's built off of something called a container. And there's a standardized way of building the containers that adhere to something called the OCI spec. And everything needs a registry. And the whole story of a developer being like, It runs on my laptop. As long as it's a container and it runs on their laptop, it can run anywhere as long as you have the container runtime, which is beautiful. There's a lot of different offerings out there, Podman, Docker, Builda. I'm not going to get into the nuances of that, but just as long as you understand that a container is the core building block of this world, then a lot more makes sense. You take it to the next step, and then you look at how when you want to start running more than just one application, you need a way to orchestrate all that. And that's where Kubernetes comes into play. At the very core of Kubernetes, all it is an open source container orchestration, where you give it a container and it finds a way to run the container somehow. Now, if you look here, the things that stick out, especially to a lot of businesses, is first of all, there's community support. There's not one company behind it. Yes, there are some platform certifications like AKS, EKS, and IKS, but and they do support the offerings, but there's not an actual, company that owns and understands it all behind it. And there's a limited core framework to it too, which makes it really, really important to think about. Back to the landscape.cncf.io I was showing earlier. And that's really important to know because it's confusing and it's hard. And that's where OpenShift comes into play. OpenShift, and the slide's actually a little bit out of date, but this is where OpenShift is really important to say that this is the enterprise level of Kubernetes. It actually is a production grade release of Kubernetes that has a Red Hat behind it, which will do the Red Hat enterprise support. And what is the most famous thing about Red Hat? As soon as you buy Red Hat's products, they're supporting it for 10 years. 10 years to make sure that it'll always work. And if you're moving into the cloud native ecosystem, that is you have a throat to choke, right? Like that's the saying where you need, like when something breaks, you need to call somebody on the phone. Well, you got Red Hat behind that. And of course,
it's always, as a person who works at Microsoft, where we kind of are part of the companies that helped create the enterprise along with IBM as well. It's good to know that there are these enterprise implementations to manage open source bit, because as we grow beyond just a simple project and maybe we become, part of some sort of Fortune 500 company or whatever, good luck to you. Hope it all works out that you get that successful. The tools change. Am I right?
Absolutely. Everything moves forward, right? You got to move forward with it. So, normally I go into a little bit more declaration of containerization and all that, but I want to skip through some of these things. But if you look at these images, you can kind of see what a deployment is. Honestly, I lied at the very beginning. Containers are not the smallest bit. It's actually something called a pod. I make a joke about that. But the point is that's how the actual application is ran on OpenShift or Kubernetes. And then OpenShift and Kubernetes have something called a node underneath it. That's the actual CPU that runs it. And
sure.
What's important to know about nodes also is that if you need an anchored thought to understand about Kubernetes or OpenShift, the easiest thing to boil it all down into something is all Kubernetes and OpenShift is an API to compute. If you can anchor your thought around that idea, all of a sudden a lot of the whole ecosystem starts making more sense because it's all just a bunch of APIs talking to one another. And specifically, OpenShift and Kubernetes is just an API to compute, and everything just works a little bit better around that. So we have service discovery inside of Kubernetes, and obviously we need a way to be able to communicate back and forth. Same thing with OpenShift. And because we're all engineers and all graybeards, we all love our DNS. So of course we have our own DNS inside of it too. That's a joke. We all hate DNS. You do. Anyway.
Yeah, because it's always DNS, isn't it?
It's always DNS. It's always DNS. But to start talking about where OpenShift and Kubernetes start splitting, there's a term called namespaces in Kubernetes. And that's really important. Namespaces is a way to kind of slice and dice your Kubernetes cluster into, in this case, your application and my application, or for that matter, you can do dev, QA, and prod all on the same Kubernetes cluster. And that's really important, especially for if you're a developer and you know that staging environment or that UAT that you've been doing. Hey, it's underneath that, Suzanne's desktop. Underneath there is our UAT environment, which is nothing like our production environment on the cloud. Well, with Kubernetes, you can run the exact same hardware because you use namespaces to slice and dice everything up. Is really, really powerful. Now you're actually running on the exact same CPU, which brings in that. But the most important part for me that actually got my head wrapped around why OpenShift is so valuable is if you take that namespaces and jump into something called projects. Projects are basically analogous to Git feature branches, using Git feature branches. If you use the Git workflow, right, where you create a feature branch, you do your commits and you merge it back into main. If you look at projects, they mirror those so well, it's unbelievable. And you can have like your main branch here of being payment prod, and you can have actual RBAC on the projects, which I've even heard that people have access into Azure, Azure ID or Azure ID?
Azure
AD.
Yep. Azure AD. There are some, if I'm right, there are some really good implementations where you can integrate, your access and identity into your OpenShift clusters.
Exactly. And that unbelievably powerful then. And because projects are ephemeral, right? Like you can have payment dev today's date where you make your changes and then you leave it there and let some other person come along and see those changes with the code beside them. And then when they're ready, they just merge it into the next branch, if you will, and redeploy it out to payment prod, which I'll show here in a moment. And all of a sudden you're pushing out code. And then it's just a natural progression, which is unbelievably powerful. So projects really are a superpower of OpenShift. Very, very cool. I want to get to the code because I want to be cognizant of time here. But there's a lot of different other terms inside of Kubernetes, and this isn't about Kubernetes specifically, but obviously we need some level of networking. And one of the challenging parts of Kubernetes is something called an ingress. As soon as you understand ingress, the rest of Kubernetes seems simple, because honestly, ingresses are really hard because it's actually how you map out how your microservices work from the outside in. Well, if you take that for a moment, it turns out OpenShift comes along with a term called routes. And this is where the superpower, and which you'll see here with the demo I'll do, is OpenShift. They've taken that really massive YAML that was the way ingress is done on vanilla Kubernetes and turned it into like 2 commands where you just expose the route and all of a sudden it just works because it deals with all the stuff underneath it and has some sane defaults that just works with it. That allows I love just works. Exactly. As a developer, that's even better because you can just expose that route of that version of the dev environment you're running, open up that API, do testing against it, and then just remove it if you need to. So you can actually have, it's in essence, feature flags built in to exposing resources out to the real world. And as you go into the microservices ecosystem, that ability to flip things on and off, it's catnip, man. It's all catnip. Absolutely. Okay, so that's the short of what I was going to say. I can go deeper into the ecosystem and all that, but what I want to jump into is actually showing you how this all kind of comes together. Do you mind if I do that, Jay?
I'd love to see it. And before you get started, I just want to remind everybody of a few things. Remember, we have a poll going on right now. We'd love for you to go and take part of it. We're asking if you are currently implementing OpenShift for your Kubernetes deployments. Head over to aka.ms/learntv. You can answer the question there. And also remember, if you want to get $200 in free Azure, head over to this URL. And of course, we're taking your questions. So if you have any questions, I can see there's some people watching, and I really appreciate you showing up every week. Please send us your questions. I know JJ wants to hear all your burning questions and find out how he can best help me answer them. Cool. So JJ, I'm going to give you back your screen, and why don't you go ahead and get into it?
Awesome. Thank you, Jay. So what I'm going to do here is I'm actually going to deploy this amazing Python app that I wrote to OpenShift live, and then we're actually going to make a real change to it using GitHub and the webhooks built into GitHub to rebuild it and actually deploy it for us on the OpenShift cluster. So I'm going to do all this in front of you with nothing up my sleeves. I mean, I'm not wearing any sleeves, right? Come on, Jay. Give me a smile, at least. Come on, Jay. There we go. Yeah, no, sign up on your sleeves.
I
There we
just
go.
I just
Perfect.
got these sleeves, and
Oh,
I can't get under them.
they're beautiful. They really truly are. I've always
Thank
admired
you.
them. And then we're gonna deploy this, and we're gonna roll through it, and then maybe we can talk about getting OpenShift on Azure after that, and then I have a feeling we'll be pretty much good. Okay, cool.
Yeah. I've actually got a cluster building right as we speak right now, and we'll be able to show how to log into it in just a little bit.
Perfect. Okay, so I'm going to go ahead and show that this is IBM Cloud. As you see here, I have an OpenShift cluster called OS AzgarLabs.io, and I'm going to bring up the web console here. Give me 2 seconds, and because computers, they get angry at you. This is the console. Now the beauty of this is as soon as Jay's instance is up and running, also, it'll be the exact same as that we are seeing here, because again, what is OpenShift but a unified platform to be able to administer and run your application? I'm looking
control
at
plane.
Exactly. Thank you. That's the word I was looking for. So as you see here, I'm the administrator. I'm not going to deploy administrator. I'm going to deploy developer here because that's cool. And I'm going to go ahead and create, as you saw here, that project that I was talking about a moment ago. We're going to create a new project, and I think we're going to call J is awesome. We're going to call that the project because that's perfect, right?
Thank you so much. I appreciate that vote of confidence about my awesomeness.
There we go. There we go. So what we're going to do is just to reiterate again, I go ahead and bring this up, and this beautiful Python app has this wonderful app.py. And what does it do? It literally just returns, I'm flattered Eric asked me to do this, because I did this last time for Eric Wright, because I was really flattered that he asked me to do this talk. And what we're going to do is we're going to deploy this, and we're going to actually see this work. So I go ahead back to here we go, and we're going to grab, we are going to do it from Git because we're going on GitHub here. I'm going to take that URL, which I should have copied real quick, and I'm sorry for that. So we're going to go to code, and we're going to do it HTTP. I'm going to copy this. I'm going to bring this back over here. I'm going to throw this HTTP, which you can too, by the way, if you're watching. And I'm going to go ahead and throw this in here. And it already validated it. And look, it already figured out that it was a Python app. Like, I haven't done anything. I just posted the damn thing in there, and it's already told me it's Python, which is pretty cool. It's already giving me this.
It looks at the dependencies and looks at the actual code itself, and then makes a determination. Well, I guess instead of service discovery, it's like code discovery.
Yeah, exactly. It's exactly. And it's building right off of the UBI, which is the universal base image, which is something up from Red Hat. So this will be actually a supported Red Hat instance because I'm running off of the UBI, which is really, really neat. I'm going to call this, we're going to call this Cloud Native Azure Bytes, just to be on the safe side, because I know names are always a problem. I'm going to go ahead and post that in there. And we're going to create that deployment that I was mentioning earlier, just to make sure that it's actually there. And as you see, we actually, because of that ingress problem and how difficult it is, and I'll make this just a little bit bigger.
Yeah, thank you.
It actually has, you can create the route on the fly. So I'm going to go ahead and just push this as, and I'll go ahead and hit create right now. And as this goes, maybe we can answer a question or two, because it takes a second or so to build it, because I'm really building it live.
Well, we have a question here, and I will bring it up. So DK wants to know, what are rolling deployments?
Oh, that's a great question. Jay, do you want to take that?
I'm off the top of my head. I would imagine rolling deployment is building a continuous release pipeline of when new changes are made. They roll out automatically like a GitOps. I'm guessing. I will look up the actual rolling deployments with OpenShift explanation. Let's see if I can pull it up from the docs right here.
Well,
because it's a deployment.
Yeah.
It's part of their official deployment strategy.
Yeah, and I'll yes and that, which is it sounds exactly what it is. When one thing changes, however large your deployment is, it'll attempt to update that or rebuild it, as you see here for a moment, as you see my build is happening with number one here, it'll see that, how many containers are built inside of there. It'll try to, it'll change out one of the containers, validate that it comes up, because you can do liveliness probes or readiness probes inside of it. And then if everything checks out, it'll do the next one. And then before you know it, you have a natural release of the actual code, which is great.
Very cool. And here's the official definition. The deployment strategy determines the deployment process and is defined by a deployment configuration. Each application has different requirements for availability and supports different deployment scenarios. So a rolling strategy slowly replaces instances of a previous version. So kind of what I believe when you deploy to when you push new changes, it will then replace what you've got there and help you prepare your new environment, I suppose is the best way to put it.
Perfect. So as we were killing time just chatting there, as you see, we've got our build complete. We have a nice blue circle to say that it's up and running. We're exposing port 8080. That's by default. You can change it to whatever you want, but just trust me, go with the defaults. And then as you saw here, we have that route. So if I go click this route, all of a sudden, I'm flattered Eric asked me to do this. So we've already taken our code and deployed it, right? Which is cool, but that's not the win, right? Because as a developer, deploying your code should be easy, but making the change is what should be most important. So what we're going to do is I'm going to actually go into this builds right here, and then we're going to go to this build config. At the very bottom, you'll see this GitHub right here. And I'll go ahead and copy this URL with a secret, and I will bring up our repo again. And hopefully I've already prepped this, and I don't know if I did, and I didn't. So don't pay attention to that. That's not important. Don't look behind the curtain. Exactly. So, okay, I have no webhooks on this thing, right? So I take that exact same URL, and I go ahead and throw that in here because this is actually out on the real internet. And then I'm going to change this to JSON because, JSON's important. I'm going to go ahead and add a webhook. I'm going to just throw everything because it's fine. And I'll go ahead and click this link. And as you see here, GitHub has already acknowledged, hey, there's something there. That's pretty cool. This is OpenShift already having this built in. I didn't have to add anything. This is just OpenShift doing its thing. Now, what I can do is I can come back to the code. Where did I put the code? I put the code here, didn't I? And I'm going to do it because Jay's my buddy. I'm going to go ahead and hit this edit button. And you know what? I think I'm flattered that Jay asked me to do this, because that seems pretty reasonable.
Thank you very much.
Nice. And because I'm bad, I'm going to go ahead and commit this to master. And I know it's supposed to be main. I'm sorry. But I went ahead and did that.
It's a demo. Sometimes you commit to master when you're doing a demo. Or main, I should say.
Exactly. So we'll go back to that builds here. And then we'll go to the topology. And we're still saying Jay is awesome here. And if I click this link, all of a sudden, less than a minute ago, because the webhook's already set up, the build's already started. So I've already put in actual CI. So I made the change. The webhook was like, oh, cool. Pushed it over to my repo. It's already in. There's, again, nothing up my sleeves. We're doing this live, right? So as we wait for this, and if we keep an eye, there's only one pod running, but if we keep an eye on it, you should see, just back to that DK's question, the rolling deployment, we should see one come up, and then when it's good, which could be a Java app, could be anything, it'll get the other one good, and then it'll destroy the other one. And then all of a sudden, if I refresh this little link right here, I don't think Eric will be flattered, or I don't think I'll be flattered that Eric. I think it'll be Jay.
Let's take a look.
Let's see.
Yeah, we'll wait for the deployment to finish. And while we're waiting for that deployment to finish, I have a question for you. So is a lot of this saved in logs so that we can go back and validate what we've had if we need to do some investigation or something like that? Oh, there
Absolutely.
we are.
Right here.
Love it.
All the build.
As an ops person, but at heart, I love when we're able to get logs or look at like live terminal response. Like that's one of my favorite things about GitHub Actions specifically is that I can go in and take a look at the logging that's going on.
Uh-oh. Uh-oh.
Oh
Where is it?
no.
Hold on. No. Sometimes it gets a little funky.
Hey,
Oh,
when
there
you
we
do
go.
it,
Hey!
hey, when you
Yay!
do it, and you do it live, right?
Exactly. Had to do a hard refresh because caching. But yeah, so that's OpenShift in general, right? Like if you're taking it from a 5,000-foot view, and you're probably wondering, like, why should I care? The short of it is it's a bunch of opinionated ways to get the cloud native ecosystem to be running your application that can be a unified platform between multiple clouds and on-prem. So as a developer, and DK, because I'm going to pick on you because you said something, maybe you're a developer and maybe you're trying to find a way to do a good way to deploy your application in a safe way for velocity and security. OpenShift gives you that.
Yeah. So how does security kind of fit into the question? Do you have anything you can show me in that portal around like compliance and security that I know is really important?
I yes, and I shouldn't have said that word because I don't have it practiced. So, but the short of it
Okay.
is there's a lot of great cluster management solutions on top of OpenShift, and Schaefer knows these all too well. And there's some really awesomeness around compliance to validate to make sure that you play within the rounds that your company has told you to do. I know they have some like out of the box compliance profiles that you can literally like 2 clicks, and I wish I knew them off the top of my head, and I don't want to just fumble around trying to do that here. But when it comes to compliance, especially HIPAA and PCI, I know for a fact OpenShift has that stuff very readily available for different companies.
And how about that little monitoring tab? Can you show me a little bit about that? Because one of these things that I was thinking about is that, one of the important parts of actually deploying a unified kind of control plane is being able to have all of your monitoring information in a single pane of glass.
So I've forgotten where it is. It used to be in here. It used to actually give you Grafana. And I don't remember where the exact link is off the top of my head. Maybe it's because I need to be an administrator. Hang on. So if you look inside of it, here we go. If I go into dashboards, there we go. I can actually see, there we go. Here's the Grafana UI. Has Grafana built in, so you can actually build all of your custom Grafana dashboards to see where everything is and everything comes together. Anyway, you get the point. It's all built inside of here. We've got some great things around everything we need to. So as an old ops or DevOps professional or SRE, whatever you want to call me, and I needed that dashboard up on my wall. It all comes for free inside of OpenShift.
Gotcha. So I've actually kind of got one building in the background.
Yeah.
Let me pull up and take a look. 1 second, it'll come up. Here we go. There we are. So I've got a cluster right here. As you can see, it's pretty typical Azure stuff here. We have our resource group, the location, the version of our OpenShift, the console version, which hasn't been updated yet, then the actual worker VM count. And I'm pretty sure if we go behind the scenes into the resource group, we'll see some of the more important components. Let me see if I can bring this up a little bit so we can take a look. Come on.
Thinking about it. Thinking about it.
Yeah. Let me bring this over to a different spot here. Okay. I want to make sure that I can make it a little bit bigger, and I'm limited over here. Okay. Here we are. So let's bring this up. Cool. So what we'll see here is we got our resources and we've got a virtual network, which our OpenShift cluster lives on. And then our actual cluster itself. And so the Azure Red Hat OpenShift documentation, it's right here. It's pretty straightforward. And I think maybe since I've already got one building, that's cool. But let's quickly show how we could actually build one.
Yes, please.
I think. So let's talk about two things first. There's a couple different methods that you can choose. One of the methods that I think that if you want to do it through an automation process, there is this ARM template, and I will go ahead and put it in the comments so you can take a look. And what this ARM template essentially does is take some parameters that you provide it with, and then deploys using Azure Resource Manager your requested cluster with all the existing parameters, so you can actually do it once, and then because it's codified, and let's browse it on GitHub, you'll be able to go back and store it in your chain, in your repository, so that you can keep all that information stored. And if you need to make modifications, you need to iterate upon it. So you can take a look. There's a whole bunch of prereqs. There's some scripts here. They create service principles so that you can have that built trust, and you don't have to create a username and password for certain actions that happen between the back-ending virtual machines and the actual platform. The deployment of OpenShift. So there's all this, but then there's a pretty cut and dry way of doing it. So there's some great tutorials, JJ. Mm-hmm. And if you go to this create an ARO cluster, you'll actually see that it gives you that whole run through. And so why don't we kind of go through this? So let me go ahead and bring this up. We'll bring up our Cloud Shell. And so the first thing that we're going to do is have our Cloud Shell come up.
I do, Jay, if you don't mind me just throwing this in real quick, especially sure. If you're dipping your toe into this world, you might get overwhelmed with how much is required to run OpenShift, but it's because it really is a production release of it's designed to run production code. It's designed for redundancy.
Enterprise is, I think, a key term that you use. So there are a ton of things that you're going to have to concern yourself. And so there are a lot of these steps that allow you to customize your new cluster creation. However, what we're going to do is kind of fast forward, and we're going to just do some of the Azure bits and pieces. So we needed a virtual network that's containing our two empty subnets. So what I'm going to do is we'll go back to our Cloud Shell, and I'm just going to open code just so we have like a scratch pad. Mm-hmm. Mm-hmm. And so let's make this a little bigger. And now let's run through it. So what we're going to do is set some parameters as variables, I should say. And those variables are pretty self-explanatory. So let's go ahead and just change something because I have already created this resource group. I want to change the cluster name. So we're just going to call it cluster 01. And so all we have to do is take these and go into our Cloud Shell, pop them in. And so now we have these specific settings set as variables. So as we create things, they'll be ready. So the next part that we would be doing is creating a resource group. We don't need to. I've already created a resource group. If you don't know what a resource group is, the best way I like to think about it is a carton of eggs. So when you have a carton of eggs, you're able to put resources inside. You're able to take them out. You have more than one carton, you can take an egg and put it from one carton into another. And if you're unhappy because all the eggs are spoiled, you can pick the carton up and throw it in the trash and be done with it. And so that's the way we were kind of. So after you've created your resource group, you'll go ahead. So we'll just kind of show you real quick. It throws some JSON back at you. So AZ group create. You pick a resource group, a location, and then you get a little bit of JSON back of saying and confirming, yep, that's what we did. So the next step we will go to is we're going to create a virtual network. And I have already created this virtual network. We give it a default address prefix 10.0.0/22. For those of you who aren't super up to speed on networking, this tutorial is going to save your life. And one of the big reasons why is that they've made a little bit of these decisions for you. So we create a virtual network, which is just an IP space for us to work in privately. And then we could take that if we want. And we talked a little bit about hybrid. If we have, say, multiple networks, we can create, say, a site-to-site VPN, or even use some VPN virtualized software, and connect these two so that we can create these hybrid networks so that, say, a cluster on the IBM cloud may want to hit a private API on Azure. We can configure those. These are all really, really important and the main concept of a hybrid cloud. So what we've done here is we've created some subnets for our private, or I should say for our master nodes, and then some for our worker nodes. So JJ, can you give me a big explain, or I should say a short explain on the difference between those two types of nodes?
Absolutely. So the master node needs to at least be 3, if I'm correctly, because they can have a split brain problem. 3 VMs or 3 containers or 3 instances where they are the actual APIs that control the OpenShift cluster. They have quorum. And there's an etcd instance between them to store all the information that needed. They hand off all the work when you give it the code or whatever in the build. The actual workers are the ones that actually run the actual container and or pods to make sure that the actual thing happens. So you can actually have master nodes completely isolated on private networks and only have your workers, for instance, on the public internet. So you can have all your control plane protected inside of your firewalled network, as long as they can talk to the worker nodes and know that they are the ones that they're supposed to talk to, which is done by, really crazy security that I couldn't explain if my life depended on it. That's supposed to be a joke. That you can work with it. Just exactly like what I did on IBM Cloud.
Cool. And so now let's go ahead and we'll create our cluster. And so one of the great things is that there are so many existing resources in the Azure Cloud Shell, or I should say sub-commands of the Azure Cloud Shell that allow you to create all these resources. And so in this point, we're just going to be leveraging the ARO. And if we just do AZARO, you'll get a list of what it is we can do. And so here, AZARO list. What we're going to do is see, I've got one. Actually, let me do that with output table so we can get it in a table view instead of that JSON. So we're going to see I've already got a cluster. And right now, I've got a URL that I can use to log into the front end of my cluster. However, I think my, no, there it is. So I don't have a login right now, but I could create one. Let's go back to the actual cluster creation. And so when we create our cluster, we're going to specify our resource group, the name that we've chosen, and we set that as a variable. If we see here, echo cluster. We've got it named as O1. And then we have 2 subnets underneath this ARO VNet that we've created. And so all we have to do is just dump this command in, hit enter. And now what's going to happen is Azure Resource Manager is going to take these parameters that we've specified for our cluster creation and we used this term before, control plane, is go ahead and use a unified control plane for managing Azure resources called Azure Resource Manager, and then deploys it. And so once you finish deploying it, we can go back and we can take a look at our dashboard. Let's bring it back up. So let's bring up our portal. Of course, my computer is running slow because, as JJ said, when you do these things live, of course, nothing works the way we're just going to expect it. Portal.azure.com.
So I got to learn how to tap dance occasionally, you know, and be like,
Yeah,
"Hey,
yeah.
let's talk about this over here. Don't look at the
Sure.
don't look at the curtain. Don't look at the curtain."
Sure. So we'll go to ARO-RG, and so you can see I've got a cluster already created.
Perfect.
And it gives actually the URL for our OpenShift console. It shows our VM worker count. And then, of course, there's a way to export this. So we talked about ARM. And what we can do is if we want to actually save a lot of these settings, put them into our source control, what we can do is download this. And it will save and export a template with Azure Resource Manager and give all these specific parameters that are within. There's also a parameters file. So if we have OpenShift cluster name, we left it as null. Virtual ARL name, we left that null as well. But all that's located. So I think if I go back into my dashboard and let's take a look.
Jay, I actually have a question about that.
Sure.
With the ARM template that you export, is it tied to your permissions, or is there a way, like, could I take that and run it as me, or how does the permission structure work around that?
So ARM templates are generalized up until the point. Let's see. That must not. Yeah, no big deal. We've already created it. We'll go back into it another time and we'll take care of this. But we've already created our cluster. But that was the get-go. And once we've finished, and let me switch to my terminal real quick. Let me change screens. Once you've actually created everything, and I'll pick window, and we've got about 8 minutes left. So you and I will start wrapping up in just a few minutes, but let me bring up my terminal. Share. Let's go. Here we are. So once I've actually finished creating, using that command that we were just showing before, you'll see that it gives an API server profile, the IP address, that URL that I talked about. So it's a fully qualified domain name to access our portal. The console profile, same thing, fully qualified domain name. The ingress profile, the IP, allowing access to our front end. Then our cluster, what it's been created under, the pod seeder that's been set, the service seeder. So they're two different networks, both private. They're not exposed to the internet. Then we get some more information here. We got our worker profile. So one worker here, the disk size, 128 gigs. The next one. So we've got our 3 workers. And so let me bring back, and I want to show you. So the Azure portal kind of hides some of that, all those resources in that specific section that we showed before. Let me just bring up Edge again. Share. And so go in a cluster. Here we are. So over here, you can see all those resources that we created. They're all right here. They're all kind of the typical Azure resources. So like, as you can see, here's the virtual machine. That's one of our worker nodes. That's right in here. It actually shows you our worker subnet that we assign to it. And you can see all the connected devices, and this is important to those of us who love the nerdy aspects. And one of the things that's super important is that you can also export this. So another thing where if you want to just, and so you're not necessarily going to be deploying all of this you want Azure to deploy for you. That's why we have that separate little section where we just see OpenShift cluster, information about your OpenShift cluster. All these other resources we don't necessarily need to expose if we don't really care about them. But if we do and we want to save them, there are all these parameters that we can have if we need to set. And the template itself is within here. You can see all the resources that are created, allowing us to build this. And so the one last thing that I'll show is that once we've actually created all this, if we want to log in to our cluster, sorry about that, we'll go to connect to an ARO cluster, and we'll just follow through the documentation real quick. It kind of reminds me of Azure Kubernetes service, where you can just list the credentials. So let me just make one change here. Come on, Cloud Shell. You can do it. Let me see if this one, there we go. So let's change it to cluster equal cluster. So we'll list credentials for individual clusters and see, and don't you worry about it. You will not be able to use this password by the time we're done, everybody. So don't get any ideas. And so now we actually have our username and password. So I can just take that and we can store that somewhere that's safe, like some sort of locker. And so we've got our username and password. We can go to the cluster console. We have that up already. And so let's log in, okay?
Yeah.
So let's grab our username, kubeadmin, and we'll get our password right here. And boom goes the dynamite.
Hey, that looks very familiar, doesn't it?
Yeah, so just like what you had built on your cloud, we're doing the same exact thing on Azure. No difference as far as like what's underneath. It's compute, it's networking, it's storage. Those are all the things that you're pretty much creating, and you're just exposing it, or I should say you're just deploying it using different methodologies. Like I said, on Azure, using Azure Resource Manager, I'd imagine on the IBM cloud, there's a different method. And then what we can do is we can bring these all together in a hybrid cloud solution. And that's almost all the time we have, JJ.
Yeah.
We did some cool stuff together. You showed me deployments, specifically a kind of a rolling deployment on the IBM cloud with OpenShift, and then I showed quickly how we can create an Azure version of it, an Azure OpenShift cluster, and then we got our credentials. We logged in, and if we want to delete it, you know what's the best thing we can do, and it's so easy. All we have to do is AZ group delete name cluster, or I should say resource group, and I believe it's
you're throwing away the egg carton, right?
Yes, and so and then I'll just say Y and AZ group list put table, because I don't always remember everything. And so all we have to do is ARO, excuse me, not AGO. And then it starts deleting everything. So JJ, we've built some stuff, we've destroyed some stuff. How can people get in touch with you if they want to keep talking to you? I really appreciate you doing this with me today.
Yeah, man. Yes, please reach out at JJ Asghar on Twitter, just as you saw below me. Or believe it or not, I really do have the email address of awesome@ibm.com. So you're more than welcome to reach out to me there. I'm here. My job is to be a resource to help people. So if I can help, all you got to do is ask.
Awesome. Hey, thanks a lot, JJ, for being here today. Everybody, we're going to catch you next time on Azure FunBytes. We'll see you. We're going to give you the big wave goodbye. Take care, everybody. Have a great rest of your day and a good weekend, too. Bye-bye.